not that big. So there's my vertical asymptotes, my horizontal, and we have a 0 at x equals 0, so right here, and at x equals 1, 2, 3, 4, right there. All right, time to get some points. So alpha y equals enter. I've got x squared minus 4x, 4x squared plus 4x minus 24. And again, I have more than one asymptote, so I need to see both of them and make sure I have points above and below each. So my first asymptote, I'm going to use -6 and 5/8, -4 and 4/3, and then -3, this is my error, this is my undefined place. This is my first vertical asymptote. Then I've got -2, -3/4. I've got 0, 0, 1, 3/16, and then I'm back to my other vertical asymptote. So another undefined spot. And then I have 3, -1/8, 4, 0. Okay. So -6, 1, 2, 3, 4, 5, 6. So 5/8 is bigger than 1/4. So my horizontal, I know it's hard to see because you're kind of estimating as best you can. But I know that this, even if it doesn't look like it's at 1/4, and I know that 5/8 is bigger. So that means, I lost my spot, 1, 2, 3, 4, 5. That means I'm above it. I'm close to it, I'm above it. And then I have -4, so 1, 2, 3, 4. And 4/3 is a little bit over 1. Then I've got my asymptote. Then -2, -3/4, so not quite -1. 0, 0, I already had on there. 1, 3/16. So 3/16 is under the asymptote, right? Because 4/16 would be 1/4, and that's where my asymptote is. So 3/16 is a little bit under it. And then I have 3, 1, 2, 1, 2, 3, 3, -1/8, so a little bit down here, and then my other 0. So again, I would look at the picture on this one. If you look at the picture, this one is what we've been used to graphing. I connect these two, and this one's kind of what we've been used to graphing. But the middle part is not what we've seen before. It actually crosses the horizontal asymptote. We haven't done any yet that cross. So you can never cross a vertical asymptote, because a vertical asymptote is what makes your denominator 0, and we can't divide by 0, that's undefined. But you can cross a horizontal asymptote. In this case, we do. So in this case, I'm going here, and then here. So kind of a point of inflection. So definitely be checking these on your calculator, especially if you're not sure what it's going to look like. All right, so my domain, just like the last one we did, we start from -infinity, but we have to stop at the vertical asymptote. Then we start, then we stop, then we start, then we stop. So this one, we started at -infinity, stop at the first vertical asymptote you see, which is at -3. Then I start up again at -3 and stop at the next one, which is 2. Then I start up again at 2 and I go to infinity. Now, what about my range? If I cross the horizontal asymptote, is there any value of y that I'm not including? No, I'm including everything. I'm coming down here, and I'm going up, 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 and I'm never taking my pencil off the paper. So my range includes everything, -infinity to infinity. Any questions on that one? All right, moving on. We got a factor again. Difference of squares. I hope by now we're all getting really good at recognizing difference of squares. How about down here? Can I factor anything from the denominator? The 3. Okay, does anything cancel? Nope. All right. How many vertical asymptotes am I going to have? How many values will make the denominator 0? Just one. All right, which case is this? Is it Bobo, Botan, or Eats DC? Is it bigger on the top, bigger on the bottom, or are they the same? So I have x squared and x. Bigger on top, bigger on bottom, bigger on top. So this is Botan. Bigger on top, none. So my horizontal asymptote is none. All right, my zeros. If I set the numerator to 0 and solve, how many zeros am I going to have? 2. What are they going to be? All right, let's get some other values. Actually, let's get the asymptotes on there first. So we've got a vertical at x equals 1. There is no horizontal, and I have 1, 2, 3, 4. That's a 0. 1, 2, 3, 4. That's a 0. All right, let's get some other values. So alpha y equals enter x squared minus 16, 3x minus 3. And I only have one vertical asymptote, so I'm just looking for that one. And I need a couple above and a couple below. So I've got negative 2 4/3, negative 1 5/2. 1 is my error. That's my undefined. That's my vertical asymptote. 2 negative 4 and 4 0. And again, I'm picking points. You might pick different points. As long as you have 2 above and 2 below, you're fine. So negative 2 and 4/3. 4/3 a little bit above 1. Negative 1 and 5/2, that's 2 1/2, so 1/2. 2 negative 4, 1, 2, 3, 4, and 4 0. And again, if you haven't graphed one, you might want to hit your graph button on your calculator before you draw, just to see. Because we haven't done one that doesn't have a horizontal asymptote. So this one goes like this, gets closer to that vertical asymptote. And the same thing here. Down here it gets closer, but then kind of goes off. All right, so my domain, I start from here, I go, I have to stop at the vertical asymptote. Then I can keep going. So I start at negative infinity, asymptote, start going again, and go to infinity. How about my range? Are there any restrictions on my range? Is there anything that my y value is not? Yes, no, maybe? If I'm coming from down here and I'm going up, 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 up forever, I'm starting at negative infinity and I'm going to infinity. There's no breaks. There's no stops. Any questions on that one? All right, last one before the quiz. So again, we got a factor, always factoring. So on the top, two numbers that multiply to be 2 and add up to be 3. On the bottom, there's a GCF of x. Is there anything I can cancel on this one now that I factored? Yes. Here and here. They are the same. So I can cross them out. So I end up with x plus 2 over x. So how many vertical asymptotes do I have? Do I have 1 or 2? 1, because I've crossed this one out. So the thing that makes my denominator 0 is 0. All right, which one is this? Is it Bobo, Botan, or Eats DC? Eats DC. Exponents are the same. Divide coefficients. So what's my horizontal asymptote going to be? 1. All right, for my zeros, if I'm looking at this, what makes my denominator 0? X plus 2 equals 0. 0. What's x? Negative 2. 2 negative 2 is 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 negative 2 All right, now we talk about holes. So I canceled this out, and I got this. But this isn't my original equation. This is my original equation. So I have to take into account the fact that I did cancel these. And when I canceled them, this, if I hadn't canceled it, would have been an asymptote, right? If I hadn't been able to cancel, if it was just that, I'd have an asymptote at -1. -1 causes a problem because this is not my original equation. So basically a hole is when you've canceled a variable and that variable would have caused a problem. That variable would have caused a vertical asymptote if you hadn't canceled it. So that's what a hole is. So a hole is going back and looking at what you canceled. What makes this value 0? What x value, if x plus 1 equals 0, what makes it 0? Yeah, that's my hole. So my hole is going to be at -1. And my y value here, if you plug -1 into here, -1 plus 2 is 1. 1 divided by -1 is -1. There is a hole at -1, -1. All right, so let's get our asymptotes on there and get some points. So we've got vertical asymptote at x equals 0. We have a horizontal asymptote at y equals 1. And we have a hole, or we have zeros. We have a 0 at x equals -2. And there's a hole at -1, -1. So right here, I'm going to make it kind of big, there's a hole. So now let's get some points. So y equals alpha, y equals enter. We've got x squared plus 3x plus 2 over x squared plus x. So 2 above and 2 below your vertical asymptote. -4, 1/2. -3, 1/3. And then I've got 0. That's my undefined. 1, 3. And 2, 2. All right, so 1, 2, 3, 4. -4, 1/2 is about here. -3, 1/3 about there. 1, 1, 2, 3. And 2, 1, 2. So when you draw this, make sure you leave that hole there. That's why it's good to put the hole in before you start drawing your line. So now because of the hole, I have a couple other issues when I do my domain and range. When I start going from left to right, I go, I have to stop at the hole. Then I go, I have to stop at the vertical asymptote, and then I can keep going. So my domain is, I keep going until I hit the hole. The hole's at -1. I start up again at the hole, and I go until I hit the vertical asymptote, and then I hit the vertical asymptote, and I keep going forever. And the same thing with range. When I come up, I'm going to be coming up, up, up. Oh, I have to stop at the hole. Then I go up, up, up. I stop at the horizontal asymptote. Then I can keep going up. So up, 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 stopping at the hole, up, up, up until you hit the horizontal asymptote, and then to infinity. So any questions about the ones with holes? Again, it's where there would have been an asymptote, but you canceled it out. It's a problem. A hole is a problem. It makes the denominator be 0.